Okay, so our first one, we've got lithium and we've got chlorine, ionic or molecular compound. It's ionic because lithium is a metal. Okay, so we would name this according to the ionic rules, which is name the metal first and the non-metal second, and make the non-metal end in "ide." Okay, simply lithium chloride, no prefixes. There's no Roman numeral needed here because lithium is only ever +1. It doesn't have a secondary charge. All right, for number 2, we've got chromium with fluorine. All right, this is also going to be an ionic compound because chromium is a metal. But chromium is a special metal. It has more than one possible charge. Okay, what are its two possible charges? 2 and 3. So we've got to figure out which one it is. Now looking at this compound, it looks like it should be pretty obvious. Okay, so what I do is I write the charge next to fluorine. All of our nonmetals only ever have one possible charge. So the charge on fluorine is -1, and there are 3 fluorines. So -1 times 3 is -3. So there's 3 negative charges in this ionic compound. All ionic compounds have to have a charge of 0. That means I need to get 3 positive charges from a single chromium atom, which means the charge on that chromium atom is +3. So this will be chromium, Roman numeral 3, fluoride. Okay, questions on that one? Remember that we only need Roman numerals on ionic compounds where the metal has more than one charge. Right? So we always have to look. Okay? Even if you remember what the name of something is, still look at the periodic table to double check and make sure it isn't one that would need Roman numerals. All right, for number 3, I've got phosphorus and bromine. These are both non-metals, so this is a molecular compound. So I don't have to worry about charges. I don't have to worry about Roman numerals or anything like that. I just have to write the names. Okay, phosphorus, there's only one of it, so I don't need to put a prefix on it, but there are 3 bromines. So this stuff will be phosphorus tribromide. All right, number 4, I've got zinc and iodine, ionic or molecular? Ionic, zinc is a metal. Okay, does zinc have more than one possible charge? No, it can be a 2+ and that's it. So it only has one possible charge. So do I need Roman numerals? No, I don't. Okay, I only need Roman numerals if there's more than one charge. There's only one charge here. All right, so this stuff is going to be zinc and iodide. Okay, remember, I don't need any prefixes. Okay, didn't need any Roman numerals. It's just zinc iodide. All right, how many people are done number 5? Okay, let's look at number 5. So I've got silicone and oxygen. All right, silicone is a non-metal, so is oxygen. So this is a molecular compound, which means I'm going to need to use prefixes in the name. I'm not going to need Roman numerals, okay, or anything like that. So this stuff will be silicone dioxide. All right, and then we have number 6. We've got carbon with sulfur. Both are non-metals because they're on the right-hand side of the staircase. Okay, there's only one carbon, so it doesn't get a prefix. Okay, and then there's 4 sulfurs, so that would be carbon tetrasulfide. Okay, and guys, the only way to get good at this stuff is to practice it. Right, the more you practice it, the more automatic it will become. All right. I want you to try the rest. You are going to get to a few here where there are polyatomic ions. Remember, the rules for polyatomic ions is look them up in the little table there and write their name exactly as it appears in that table. So for number 7, I've got technetium and iodine together. All right, so this stuff here, is it ionic or molecular? It's ionic. Technetium is a metal. Okay, it actually doesn't exist in nature. It's man-made only. And then we have iodine here, so we're going to have just technetium iodide. Okay, we don't need any Roman numerals. Technetium's always a +7, okay, when it's in the compound. All right, number 8 is our first compound that has a polyatomic ion in it. Okay, so we have to do a little bit different with the naming. Now, because it has a polyatomic ion in it, it has to be what kind of compound? Evan.
Polyatomic.
Okay, it has a polyatomic ion in it, so it's what kind of compound? Ionic or molecular?
Oh, it's molecular. Ionic.
Ionic, right? It has a polyatomic ion, so it's an ionic compound, right? Anytime you see a polyatomic ion, you're always dealing with an ionic compound, right? So this stuff here, Na is sodium, and what does OH stand for? Hydroxide. Sodium hydroxide. This stuff is the active ingredient in oven cleaner. Okay, so if you've ever sprayed that white foamy stuff on the inside of the oven, or mom and dad have done that when they clean out the oven, okay, that's the active ingredient. It has an incredibly harsh odor, and it's incredibly basic. Like, you don't want to breathe it in. It would give you a chemical burn in your lungs. Okay, so you always want to use it in a well-ventilated space. You don't stick your head inside the oven while spraying it, or that will be very bad. Okay, the fumes from it could even hurt your eyes, right? So you want to stay away from it. It's very, very basic, very caustic, so it would like dissolve tissue. That's what it's doing inside your oven, dissolving all the crud on the inside. Okay, so you want to kind of stay away from that stuff. All right, I'll give you a few more minutes to get a little bit further ahead of me, and then we'll go over a few more. All right, so again, with number 9, we have something that has a polyatomic ion in it, so we know we're dealing with an ionic compound. So we're not going to need any prefixes. Okay, we just need to name the 2 parts. So Ca stands for calcium. And what is SO for? Sulfate. Okay, make sure you don't get confused sulfate and sulfite, right? Sulfite is SO3, sulfate is SO4, and there's a difference there. Okay, and technically, this does not need brackets. Okay, I didn't have to put a number outside of the brackets, therefore I don't require brackets on that one. All right, let's look at number 10. What does K stand for? Potassium. Okay. And what is MnO4? It's hard to pronounce. Permanganate. Potassium permanganate. Okay, potassium permanganate is these little purple crystals. Okay, they're actually quite pretty, but you don't want to touch them. Okay, they actually used to use them way back in the day as a fungicide. So they would make like a solution of this stuff, which is really a dark purple color. And then they would soak like people's feet. If they had like bad athlete's foot and stuff, they'd soak their feet in it. It would kill the fungus because it's quite like harsh stuff. The other problem with it is it will stain your skin. And so if you have really light colored skin, it will stain your skin brown. Okay? And I used to have a lab that I did with this. I had a kid in my class who never, ever listened. He never listened to a word I said, and he was just like pasty white. Okay, like he had really, really light skin, and he wouldn't listen to me. And I said to these guys before we did the lab, okay, we're using the potassium permanganate. Make sure you use the little scoop to pick it up and put it in the reaction plate. Well, a little while later, I see him with the sample plate in his hand, and he's picking up the crystals with his bare fingers. Mr. Correa, this stuff's so cool. Just like, yeah, and look at your fingers. Only, of course, where he touched it on the tips of his fingers. And he had been playing with it for so long, it was like this really dark brown. Like questioning about like, how would that color get on the end of your fingers brown? So, and it doesn't come off. Like, you can't go home and just wash it off. It actually stains the skin, and the only way for it to come off is for you to exfoliate the skin. So, like I told him, you could go home and like wash your hands with sandpaper, and it would come off eventually. But it was pretty funny, just because, yeah, like just imagine on like my skin tone, like a dark brown. only on the very tips of my fingers. It looked pretty silly. Okay. And he totally had it coming because he never listened to a word I said. So that was karma. Okay. Karma really bit him that day. All right. How many people are done number 11? Sorry, question. No, calcium only has one possible charge. No. Oh no, that's SO4 and it's 2 minus.
Oh, okay.
Yeah? Yeah, okay. All right, let's look at number 11. Okay, so number 11, I've got nitrogen and I've got oxygen. They're both non-metals, so this is a molecular compound. Okay. Okay, so we got nitrogen and then we got one oxygen. And since it's molecular, we will need a prefix on there. Okay. Nitrogen monoxide. How many people have done 12? All right, let's look at that one too. All right, so number 12, I've got beryllium and then a polyatomic ion. And this polyatomic ion is cyanide, highly poisonous. Cyanide, basically with anything, is a very poisonous substance. Okay, so this stuff will be beryllium cyanide. Doesn't matter. It's an ionic compound, so we don't use prefixes, right? All right, this stuff here, very similar, except instead of beryllium cyanide, this is going to be barium cyanide. All right, what about 14? How many people have done 14? All right, so Na is sodium. And what is HCO3? Sodium hydrogen carbonate, right. Anyone know what the common name for that is? You probably have some in your pantry at home. Not salt. Baking soda, yes. Okay, which and baking powder actually has baking soda in it, so they would be technically both. Okay, but yeah, sodium hydrogen carbonate is the technical name for baking soda. And then lastly, we got PO4. Now, sometimes what happens with a compound like this is we also notice that it's in the table of polyatomic ions. Okay, there's a polyatomic ion with the same formula, except that this isn't that stuff. This is a compound because it doesn't have a charge listed beside it. So we would name this phosphorus tetraoxide. Okay, that's about as tough as they get in terms of naming. Okay, you had a little bit of everything there. There were some molecular compounds, there were some polyatomic ion compounds, there were some ionic compounds that needed Roman numerals, right? So basically you got a little bit of everything. And that's kind of how this is going to go. Any questions on those? Okay. Now we got to look at going the other way. We've been looking at, all right, I have the formula, I got to get the name. Now I've got the name, I need to come up with the formula. All right, so the steps for this are that the first thing you need to do is figure out whether it's ionic or molecular, because the rules are, again, a little bit different for each one. So if it's an ionic compound, what will it have in it? A metal and a non-metal, or a metal and a polyatomic ion, or a polyatomic ion and a non-metal, okay, any combination of those. All right, once I've decided it's ionic, okay, and I'm trying to write out the formula, the next thing I do is I write the symbols from the periodic table for both parts of it. So let's say I've got this name written down here. Let's say they gave me magnesium nitride. I've already decided that's an ionic compound because magnesium is a metal. My next step is I write the formula for the metal, and I write its charge above and beside it. Okay, magnesium is a 2+ according to my periodic table. The other part of this compound is nitride. The symbol for nitride is N, and the charge on nitrogen is -3. What do I do with those charges? Drop and swap. All right, so the 3 drops and swaps and comes over to here. The 2 drops and swaps and comes over to here. Now I'm done. Mg3N2. Okay, so with ionic compounds, we have to drop and swap. Okay, what if I had this one? What if I had molybdenum 4 oxide? All right, so if we look up molybdenum on our periodic table, okay, molybdenum is right here. Okay, yours only has one charge on your periodic table. Oh, it's only got one. Okay, that's fine. We'll use the one it's got on there. I wrote, it's supposed to be 6 anyway. I wrote 4. Okay, so let's just say it's molybdenum oxide. Molybdenum is a 6+ charge. So I write Mo, and it's +6. All right, I write oxygen, it's -2. Now I drop and swap. I get 2 and 6. Should I leave it that way? Can I reduce those? Yes. Ionic compounds are like fractions. If you get one that you can reduce, you should. Okay, I can divide both of these numbers by 2 and end up with MOO3. Okay, ionic compounds that can be reduced after dropping and swapping should be. It doesn't happen very often, but when it does happen, you have to remember to do it. Okay, questions on the dropping and swapping to make ionic compound formulas? Okay, you guys are pretty familiar with the dropping and swapping as already. Okay, let's look at another one, but let's look at, let's say this example here. Chromium's got a 3+, right? It's got 2 different ones. Yep. Okay, so let's go with chromium 3 sulfide. All right, so I've got to write the formula for chromium. What's chromium's charge in this compound? 3. That's what the Roman numeral tells me. Okay, I see a lot of people make this mistake though. They go chromium 3 and they write the 3 down here. All right, that means there's 3 chromiums. That's not what this means. Okay, the Roman numeral isn't telling me how many chromium there are. It's telling me what the charge on the chromium is. Okay, and then sulfur is a -2. So now I drop and swap. Cr2, S3, and I'm done. Okay, so whenever you see a Roman numeral, it's there to help you make the formula by telling you what charge to use in the drop and swap. Okay, questions on writing the formulas for ionic compounds? Okay, when we're writing the formulas for molecular compounds, should it be really, really easy? It should be, because in a molecular compound's formula, what do they tell me? And they don't tell me the charge. They tell me how many of everything there is. Okay, molecular compounds have prefixes in their names to tell me exactly what I'm dealing with. All right, so in a molecular compound, we write the formula for each element. So let's say we had this one here. Okay, let's say I had dicarbon hexahydride. So carbon is one of them, and how many are there? 2. And there's hydrogen, how many? 6. That's it. Okay. Writing the formulas for molecular compounds is really easy. You just need to remember what the form or what the prefixes stand for, and you're set. There's no dropping and swapping. You don't have to reduce anything. Okay. If this was an ionic compound, would we reduce this? We would. But in a molecular compound, they told me that's how many there are. I don't have to reduce it. Okay. All right. Okay. I want you guys to try these ones here. So writing the formulas now. Okay. So we've already done writing the names. Okay. They're giving you the names. I want you to write the formulas. Okay, so just so you guys can see what this is going to look like for you in terms of the key. Okay, so if you go to classroom, okay, for your guys' class, right, they're all in there, and I think you guys are working on 2, yeah. Okay, so if you open, oh, no, that's not the right one. Whoop. So it's 3? Oh, it's really blurry, but it's because I took a picture of it with my phone. Okay. So you can see the answers are on there, and I'm pretty sure I fixed all the mistakes. Okay, so you can check as you go and see if you're doing them right or not. Okay, just call that up on your phone. Right. So on number 8, we have ammonium sulphide. Ammonium is the only polyatomic ion on your chart with a positive charge. As a result, it's the only one that behaves as a metal. Okay, so it has to be listed first when we write its formula. The formula for ammonium is NH4, and it's a positive 1 charge. Okay, it's with sulfide, which is a -2 charge. Now, if I have a polyatomic ion and I need to put a number beside it, what do I have to put it in? Brackets. So I'm going to have NH4 2S. Okay, and that's going to be my formula for ammonium sulphide. Okay, that is the only polyatomic ion that will be on the left. Okay, so for number 5, we got potassium, which is K, and permanganate, which is a polyatomic ion. That's that purple stuff I was telling you about before. Okay, KMNO4. This is a plus, that's a minus. Okay, so they balance each other out. It's just KMNO4.
No brackets.
No brackets. Don't need to put a number beside the MNO4, so I don't need brackets. Okay.
So if they're both positive, then they cancel out.
Well, it's not that they're both positive. They were just 1 and 1. Yeah.
If they balance out,
Then you don't need brackets.
But if they do,
If you need to put another number because of the swap and drop, then you got to enclose in brackets.